For this problem, we've been asked to express the following logarithms as the difference of logarithms. Recall your quotient rule. The quotient rule says if you have log base a of a quotient, then this equals the difference of two logs, the log of the top value minus the log of the bottom value. So here we have log base 17 of 4 over 7. That would be rewritten as log base 17 of the top number first, and then minus log base 17 of the bottom number. If you're able to simplify logs, you want to make sure to do so. One of the rules that we're looking for is that if the base matches the argument, then the answer is the exponent on the argument. Neither one of these two things fit that rule. Next one over, you have natural log of r over x. Okay, we see that we're taking a single log of a quotient of two values. And so this would be rewritten as natural log of the top value minus natural log of the bottom value. And that is your answer. Something important that you need to know that you cannot do. So we're going to say cannot do this. And I'll show you here. If you have, let's say, log of 3 over log of 5, that is absolutely not equal to log of 3 minus log of 5. Notice here in this particular example, you start with 2 logs, and then you end also with 2 logs. The quotient rule is this. Okay, so I'm going to say you can do this. Okay, and this is what the quotient rule specifies. If you have a single log and your argument is a quotient. Above, you see that our argument is not a quotient. The arguments are 3 and the argument's 5, and you have the quotient of 2 logs. That's not what your rule says. The rule says if you have a single log and your argument is a quotient, then that means you can split it apart as the difference of 2 logs. Okay, one of the most important things about 3 rules of logs that we have learned to this point is how you can use them, and then also what you cannot do with them. So make sure to make this note.